Doppler effect in light. In previous units waves, we discussed about Doppler effect in sound. This Doppler effect not only holds for the sound waves, in case of light waves also Doppler effect can be held as good as sound waves. So here is the Doppler effect in light means already we know that the apparent change due to the relative motion between the source and observer, there is a small change in frequency. In case of a sound waves, there is a frequency changes. The apparent change in frequency due to the relative motion between the sound produced by the source and observer is called a Doppler effect in sound. In this case of Doppler effect in light, when the source produces the sound with the natural frequency nu, when the source means the light produced by the source, when the light produced by the source, then if the distance between the source and the observer, who is the detector, is there, we are detecting the light, detector is there, between the source of light and the observer or detector, then if they are approaching together, means when the source of light is approaching towards the detector or observer, or maybe the source of light is receding away from the observer, then there is a change in frequency and a wavelength can be appears. Either when the source and observer both are in relative motion, means either moving away from each other, means the distance between the source of light and the detector or observer is increases, or the distance between them is decreases. There is a change in frequency of light, there is appears the frequency of light, change in frequency of or wavelength, change in wavelength also it appears, that we can observe that one, that apparent change in frequency of light or wavelength is called a Doppler effect in light. Means the distance between the source and the observer is increasing or decreasing, then the frequency of wavelength, frequency or wavelength of light appears to be changing to the observer. Means when the source of light is here and observer is here, whenever it is moving, the distance means the length, wavelength appears to decreases. Means here consider the total length of the total length will be lambda dash, and if in case of whenever it reaches to the sum of the distance consider lambda, then we should know this, what the distance it has traveled, the wavelength will be considered as lambda, then here it is that lambda dash minus lambda, we can consider that will be the change in wavelength, the change in wavelength, either apparent change in wavelength, lambda dash be the actual source and lambda be the apparent wavelength. Here is that whenever the source and observer both are in relative motion, if the distance between the source of light and observer is decreasing or increasing, it appears that the change in frequency of light appears increasing or decreasing. In case of wavelength is also changes or increases or decreases. So that the definition, to write the definition of Doppler effect in light is that the apparent change in frequency or wavelength of light due to change in distance between the source and observer, means when the source and observer, the distance between them is increasing or decreasing, then due to the change in observer total, the apparent change is called a Doppler effect in light. In case of formula, we can write that here is that nu means approaching frequency, this is apparent frequency, which is equal to nu root of c plus v by c minus v be the general expression for the apparent frequency when the source is approaching an observer. Source is approaching an observer means the distance between the source and observer is changes, means decreases. Then here the recession means when the source of light, the distance between the source of light and the observer is increasing, the nu recession is equal to nu of root of c minus v by c plus v. Here that nu is a natural frequency and c be the velocity of light and v is considered as the relative speed of approach or recession between the source and observer. When the source and observer are moving, it means approaching or recession, wherever they both are moving away from one another, then we consider as the relative speed between them. Then here it is that whenever the recession, here is also c means the velocity of light, v is the relative speed between the source and observer, whether they are approaching or receding, and nu be the natural frequency. In case of, it can be classified whenever the source or observer by changing its whenever they are approaching or moving away from, then the frequency and wavelength can be observed as changes. Observed some of the changes. By the changes of the observed, the electromagnetic spectrum is also changes by the receding and approaching the source and of light and observer. In that case of, it can be classified into two types of there. They are that first one is a blue shift. Blue shift means by the changes of the distance between them, the spectral line in electromagnetic spectrum shifted towards the blue, then only that is called as a blue shift. That means when the source, the distance between the source of light and observer, the distance between the source of light and observer is decreasing. Decreasing means whenever both are decreasing, whenever two persons is there, one is speaking and another one is listening, then while moving the source means which is produced to the sound. In case of light, if the light is approaching to near to you, then light will be more brighter, means more number of waves are received by you. So that's why here what will happen, the more light which can be seen, that means blue shift, means the more frequency will be more whenever the source is approaches to the, means the distance between the source and observer is decreases, the distance between the source of light and observer decreases, then the frequency is appears to increasing, and wavelength between the source of light and observer will be decreasing, means when both are approaching, means source is observer approaching, then the frequency will be more, means the more light rays can be absorbed by the, taken by the observer. So that's why the frequency will be increasing, appears increasing, and wavelength will be decreasing. So that's the spectral line, in the spectral line of electromagnetic spectrum, the spectral line in the electromagnetic spectrum shift towards the blue end, so that is called as blue shift. When the distance between the source of light and observer is decreasing, the frequency of light appears increasing, that is a wavelength of light appears decreasing, then the spectral line in the electromagnetic spectrum shifted, means displaced, get displaced towards the blue end, it is known as a blue shift, Then the change in wavelength and change in frequency formulas are the change in wavelength means lambda dash minus lambda, that is equal to Vs by C, means wavelength is decreasing. Here that negative sign indicates that the wavelength is decreasing, so that's why Vs by C into lambda, that is a lambda dash. Whenever the lambda dash means apparent wavelength will be less than the actual wavelength, apparent wavelength is less than the actual wavelength. So here it is that according to the frequency, about the frequency, the change in frequency means apparent frequency nu dash minus nu is equal to, it is can be increases, here is the positive sign is there, so there is no any sign, so that's why it considered as positive sign. Then Vs by C into nu, where nu dash means apparent frequency is greater than nu, means frequency is increases due to the distance between the source and observer is decreasing, the distance between this will be, frequency will be increasing while the wavelength is decreasing. So that's why in the spectral line of electromagnetic spectrum get displaced towards the blue end. So here it is that is called as a blue shift. That is called as a blue shift. When the spectral line is shifted in the electromagnetic spectrum, shifted towards the blue end, means displaced towards the blue end, so that's why it's a blue shift. Either the next one is a red shift. In this case of red shift, when the distance between the source of the light and the observer is increasing, when the distance between the source of the light and observer is increasing, when the light is moving away from another, we can see the light is decreasing, light goes on decreasing because of frequency is decreasing, means the light waves that cannot be absorbed by more by us, while the light of source is moving away from us, then we can see little bit decreasing, but decreasing the frequency, so that its wavelength is increases. So here it is that when the distance between the source of light and observer is increasing, then the frequency of light appears decreasing, and its wavelength appears increasing, means the distance is increasing, right? So that's why we can say that the wavelength is increasing. While the wavelength is increasing and frequency will be decreasing. We know that from the formula V is equal to nu lambda, from waves formula V is equal to nu lambda. So nu is equal to V by lambda, right? So in case of if the velocity of a light is constant, then we can consider nu is proportional to 1 by lambda. Here is that when the frequency is increasing and wavelength will be decreasing, because of it is inversely proportional. So in that case of we can write that is nu is proportional to 1 by lambda, means if the wavelength is decreasing, next in case of frequency increases. In this case of redshift, when the light ray is when the source of light and observer, the distance between both will be increases, then the frequency will be decreased and wavelength is increases. So that's why in the spectral line of electromagnetic spectrum, it is shifted, get displaced towards the red end. Shifted towards the get displaced towards the red end. So that is called as it is known as a red shift. That is a change in lambda, means we know that whenever the distance between both of them increases, then the wavelength is also increases. That means say if the wavelength is increased, it can be taken as positive, that is Vs by V. Vs by C means here Vs be considered as a source velocity by the velocity of a light into lambda, actual wavelength. That is whenever the wavelength is more, apparent wavelength is more than the actual wavelength, then here it is the frequency is inversely proportional. So that's why here the frequency will be decreases. Here is the negative sign indicates the decrement of than the wavelength, that is apparent frequency is less than the actual frequency. This is about Doppler effect in light. Once again briefly we will discuss about it. When the source of a light and the observer, the distance between both of them is changing, means either increases or decreases, there is a change appears to be as the frequency and wavelength. There is a change appears in a frequency and wavelength. That apparent change in wavelength and or frequency, there is a apparent change in frequency and wavelength is called as a Doppler effect in light. In that case of due to the changing of distance between both of them, it can be classified into two types, that is a red shift and a blue shift. In case of blue shift, if the distance between the source of the light and observer is decreasing, then its frequency is appears increasing, while the wavelength will be appears decreasing. So here case the spectral line of electromagnetic spectrum get displaced towards the blue end is known as a blue shift. In this case of when the both are coming towards, that is a blue shift. In case of red shift, the source and observer moving away from, means the distance between the source of light and observer is increases, then in the spectral line of electromagnetic spectrum get displaced towards the red end. Simply we can say that blue is a light color, right? So that is a attractive, means like that, just for the remember thing. If the blue is there, then that will be attractive color, so that's why they move each other. Red is a danger, symbol for danger. Most of the time red is a symbol for color for danger, we will consider that. So whenever the danger, we are away, we stay away from that danger symbol. So that's why here just remember that thing for easy understanding. So red shift means whenever the source and observer is moving away from, then the frequency decreased and wavelength is increased. So that's why in the spectral line of electromagnetic spectrum, shifted get displaced towards the red end is known as a red shift. This is about a Doppler effect in a light. Let's see the applications of Doppler's effect in light.